Hi everyone, welcome to another video on data structures. In this video on linked list, we are going to see how we can delete nodes from a linked list. Now these nodes can be residing at the starting of the linked list or towards the end. So we are seeing both these cases in this video. So we can begin with the logic. So what happens in deletion is when you have to delete the element or a node towards the front of the linked list, you need to just delete the memory allocated to that particular node. Alright, and the second element in the original linked list will become my first element after deletion. So that's the only thing that we need to do while deleting the first node from the linked list. While deleting the last element from the linked list, here we have to do a little bit complicated thing because the last element of the linked list is pointing to a null pointer actually. So what we have to do is we need to free the memory that is allocated to this particular node. Along with that, we need to make the second last element in the linked list point towards null. Alright, so we have two actions here. Here we have to delete the element as well as we need to actually make the second last node point to the null value. Alright, while deletion of the first element, we had to free the memory, and generally we make use of a pointer, say head pointer, that will be pointing to my first element in the linked list. So make sure that your head is kept updated, that is after deletion your head should be updated to the current first element in the linked list. So these are the two types of deletions that you can implement in the linked list. Now I will show you how you can actually do that. So this is my linked list 5 4 3 2 1 and 1 is pointing to a null value. So ultimately in the beginning head is my pointer that is pointing to the first element in the linked list. Alright, now 5 is pointing to 4 3 2 1 and so on. Now after deletion I need to free this space and now head should point to 4. Stored using another pointer temp. Now at deletion time we will delete this temp and head has to point to new head that is 4. Alright, so that is how you delete element from the beginning. And now after I have deleted 5, I have only 4 elements in my linked list. Now 4 3 2 1 and 1 is pointing to null. Now what I have to do here is I need to free the space allocated by node 1 and this 2 needs to be pointed to null. Actually occurs is temp will keep on moving from head to next element, that is from 4 to 3 and 3 to 2, then 2 to 1. Now by the time this temp pointer moves to 3, my pre will point to 4. Okay, so just preceding node will be pointed using this pre. So when my temp is pointing to 3, pre will be pointing to 4. When it is pointing to 2, it will be pointing to, this pre will be pointing to 3. Now when the temp becomes 1, that means temp dot pointer is null. So that is our stopping condition. So this is my online editor which I have used to implement this program. Now in this program what we have is I have created a class linked list. Now it makes use of this structure of name node. I have 2 elements in my node, data as well as my pointer. So this is how you can create a node, and to represent this particular data type I have used this type define statement, which I have also explained in my previous video, in which we are actually creating a linked list. So before deletion of nodes from the linked list we need to actually insert the elements to linked list. Now in this program I have actually inserted nodes towards the beginning of the linked list. That means when you are inserting an element, say 1, it will be pointing to null. Now whenever you insert another element, that is for example say 2, it will be appended to the starting of the linked list and this 2 will be pointing to 1 and so on. So that is what you can see here. I have a head pointer that will be pointing to the first element of my linked list. So this is how I create a new node. I have used this new node pointer to indicate a new node, and the data of that new node will be the data that we are passing as the value of the new node, and its pointer will be pointing to the current head, and every time the newly inserted element will become my head. That means newly inserted node, that is new node, has become my head after I have done all this initialization. So this is just to create our particular linked list before we can actually delete it. Alright, now I have two separate functions to delete at the beginning as well as to delete at the end. For deletion at the beginning, as we have already said, it's a very simple thing. You just need to move the head from the first element to the second element. That can be done by this assignment statement, that is head is equal to head pointer. Alright, and a temp variable is keeping track of the head value. So I have created a pointer node type start temp, and it is pointing to the head initially. So for example, if I have 3 pointing to 2 pointing to 1 and 1 pointing to null, initially this head will be 3. Now, and this head value will be stored in the temp variable also. So ultimately I will change the head to the original value that is pointing to the head, and head is now pointing to head.ptr, and I will be deleting the value held by, or the node that is pointed by, temp variable. Now for deletion at the end, now if my linked list is empty, I will be displaying the list is empty. Otherwise, we have to do a check condition here. So we need to keep on incrementing until our pointer of the temporary node. Okay. Now in my second function of deletion at the end, we need to keep track of two pointers. One was temp and one is previous, right? Now what this temp variable will hold? It will hold the first element as we have seen in the demonstration, and previous will be initially pointing to null. Now this is our check condition. We need to keep on traversing to the linked list until our node pointed by temp will be pointing to null value. So that is my check condition, and this prev will be keeping track of the second last element and so on, and the temp will be kept on incrementing. So initially this temp will be null, and after that with every traversal the previous and temp variables will be, or the pointers will be updated. And at the end what you have to do is you need to delete the value pointed by temp variable, and then you need to make the pointer of the node pointed by previous pointer as null. Alright, and finally we will display our linked list. So this is the function to display the node in the linked list. So you can get the source code in the description box. I will be providing the link to the file from where you can get this source code actually. So I hope this video was informative for you. Do join for more videos on data structures, linked list, as well as more computer science related topics. Okay, thank you.